Hi there, welcome back. Today we'll be looking at this problem called product of array except self. The problem states that given an array nums, return an array answer such that answer I is equal to the product of all the elements of nums except nums I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must write an algorithm that runs in O of n time and without using the division operation. So let's take a look at example 1. Given the input nums 1, 2, 3, 4, we want 24, 12, 8, and 6. Why is this? Because 24 is a product of the entire array, except for 1. So it's 2 times 3 times 4, which gives us 24. Similarly, 12, we have 1 times 3 times 4, which gives us 12. And here we have 1 times 2 times 4, and 6 we have 1 times 2 times 3. Example 2 is similar, so let's go to the whiteboard and see how we can solve this problem. Given the input array 1, 2, 3, 4, we want output to be 24, 12, 8, and 6. And we want to do this without using a division operation. So how can we solve this? The key is to use two arrays. So imagine this situation where I have two arrays. They're both initialized with ones in them in the beginning. Let's call this LA. And this RA. So what LA and RA stand for is that for LA, as we traverse the array from left to right, we'll have the current position equal to the previous position of LA times the previous position of nums. And what this is the cumulative product from left to right. So as we traverse, it would start from the second position here, because the first one doesn't have a cumulative product. So here we would have 1 times 1. So the cumulative product so far is 1. And then in the third position, we have our product that is 1 times 2. So this would be 2. And then here we have our cumulative product so far, which is 3 times 2. That gives us 6. So to make this really clear, what this array contains is the cumulative product so far. So at position, let's say this position here, we are looking at the product of the elements before this position, so going from 2 to 1. Similarly, this position here, we are looking at the product going from 3 all the way to the first element. And as you might guess, RA is going from right to left instead of left to right. So if we go from right to left, we have 4, and then this would be 3 times 4, so 12, and then this would be 24. Once we have these two arrays, all we have to do is multiply them element-wise. 6, 4 times 2 would be 8, 12 times 1 would be 12, 24 times 1 would be 24. And as you can see, this would be the output. And this is very efficient because notice how we're traversing this array from left to right once, and we're traversing from right to left once. So it will be O of 2n for these two operations, plus the final one, which is multiplying that, so another n. And this is just equal to O of n, so we have an O of n algorithm. However, we can further reduce this 2n down to just n, as we'll see in the code. Basically, instead of traversing the nums array 2 times, we're traversing it 1 time, and using Python's slicing index, we can easily do these two operations here. So let's go back to the code and see how we encode this out. Okay, so we have the definition of the solution here. Let's call our f-array LR. Again, we need to initialize it to 1, to an array that contains elements of 1s, because we're doing a multiplicative operation here, and if we initialize them to 0s, it's going to cancel out our output. And this would be our output. Let's call it product array, so P array. Remember, we start from the second element and not the first element of nums, because we're calculating a cumulative product of the arrays. So for I in range 1 nums, and notice how we're using L array I minus 1, and that is how we can get this algorithm from O of n squared down to O of n, because we keep track, we save the information of the cumulative product so far, and we use it. Oops. And here we're trying to find, we are getting the element from the right. So here we have the element that is on the left, and to do the same but for right array, you need to put a minus sign in front of I and just a -1 for the offset. Once we have the two arrays done, all we need to do now is just to multiply them together, and that will be our outcome. So it would be PRI equals to PRI times right array. Right. And we return P array. Let's see if this works. Okay, we got that. And cool. It's a success. That's it for this video, and thank you for listening. I'll see you next time.